Okay, we're going to continue 6.7 today. So a sequence of numbers was a list of numbers, right? So 2, 4, 8, 16, 32. Okay, so this sequence would be 2 to the n. Yes?
Yes.
Okay, so this is a sequence. We call it a series. When it's 2 plus 4 plus 8 plus 16 plus 32. What's the difference? I just added them. So if I had 2 minus 4, or 2, negative 4, 8, negative 16, positive 32, my series would be negative 2 to the n minus 1, actually. Because if I plugged in a 1, I got a positive, right? Mm-hmm. So I'd have to do... Oh, I'd have to do this. There we go. So this series would look like negative 1 plus 2 minus 4 plus 8 minus 16 plus 32. What's the difference? I had what kind of numbers in here? Negative numbers. So that gives me positive and negative numbers. The only time a series could have positive and negative numbers alternating like that is if it is a geometric. We had arithmetic sequences before that had a common difference. Geometric has a common what? Did we talk about all day yesterday? Common ratio.
Yeah, that.
Can you unplug yourself? Anybody else got a headphone and needs to go out too? Thank you. Okay, so this means I'm just going to add it up. We have something called summation notation, which has this symbol. I can't talk. Okay, this is a sigma. Is a Greek letter. Means find the sum. So how we write it is we have the sum from n equals 1 to whatever. I'll use 7. And then we have the definition. So n is called the index. This book uses n. Most books use I for that.
Yeah, I remember that.
1 is called the lower limit. It's the first number you plug in. Okay. And guess what 7 is? The upper limit. And this right here is the definition. Also could call an equation, right? So what this says is I want the sum of this equation from plugging in 1 to what? 7. And you don't skip numbers. You would plug in 1, 2, 3, 4, 5, 6, 7 and add them up. So if I plugged in 1, what would I get? I plugged in 1. 1 minus 1 is what?
0.
0. Anything to the 0 power is?
1.
1. So 3 times 1 is?
3.
3. So I'm going to plug in 2. So I plug in 2. 2 minus 1 is? 1.
2.
So the answer is 2. And it's positive 2, so I add it. If it was negative 2, I'd what? Subtract it. And then I'll plug in the next one and get 4/3. And plug in the next one and get 8/9. And the next in 16/27. And 32/81. And 64/24. Or 64th 243rds. Sorry. Okay, that's fun. And that means I have to find then common denominators and add that all up, correct? Yuck. You want to add that all up? No. So we have an equation. It is the sum of a finite geometric sequence. Or sequence, series. It's a series. Okay. So, what does finite mean?
It stops.
It stops. So, it stops. So, if it wasn't finite, this upper limit wouldn't be 7. It would be, what's the number that never stops? Infinity. Now, I can always take an infinite geometric sequence, one that goes ... forever, and make it finite by saying 1 to 20, 1 to 30. But I can't take something that's finite. This is from 1 to 7. I can't say from 1 to 20 now. Does that make sense? Mm-hmm. Because I can't, I'm not guaranteeing that this formula works for anything past 7. They're saying from 1 to 7 of this, and as far as I know, that's all it has. Now, if it came from a list that had ... then could I change it up?
Yeah.
Yes. Okay, so the formula is as follows. We usually say S sub n. That means the sum of the number of terms. So from 1 to 7, how many terms are being added? We'll plug in 1, 2, 3, 4, 5, 6, 7. How many terms will I get? 7. Okay? So that would be S sub 7. What if I want 2 to 7?
6.
It would be 6, not 5. Most people go 7 minus 2 is 5, right? But you have to plug in 2, 3, 4, 5, 6, 7. Get it? Okay, so n is the number of terms you are adding. The equation is a sub 1 times 1 minus n. Oh, sorry, r to the n. R to the n divided by 1 minus r. So a sub 1 is the first term, right? Mm-hmm. It doesn't mean, it's the first term, it doesn't mean when you plug in 1. Because if this lower index was 3, a sub 1 would be what I would get if I plugged in what? 3. So this is the, after plugging in the lower limit, make sense? R is R. N is the number of terms. Those n's are the same. Number of terms being, and I'm going to say added, but if it's subtraction, you're obviously going to subtract, right? Okay, so let's use this one right here. So we have the sum from n equals 1 to 7 of 3 2/3 to the n minus 1. So we need to identify a sub 1. We need to identify r. And we need to identify n. So when you plug in 1, what did we get again?
3.
3. What's R?
3.
Nope. R is the ratio. It's the base of the exponent. What's R?
2/3.
2/3. R is always going to be the base of the exponent. Always, guys. Okay? And what is N?
1. 3.
Nope. What is N? The number of terms being added. 1, 2,
7.
7. So how many is that?
7.
7. Where you guys getting 3? Where were you getting your guesses at?
Oh, for some reason I thought that the 3 before the 2/3 would be the N.
No. N is the number of things being added, okay? So I need to put it in here. So we have S sub 7 equals A sub 1 was 3. 1 minus R, which is 2/3, to the 7th. And that's the whole thing to the 7th. Divided by 1 minus R, which is 2/3. Now, there's some things I would expect you to be able to do by hand before you have to go to a calculator. Should I be able to expect you to do 1 minus 2/3?
Mm-hmm.
That would be what?
1/3.
1/3. And then you would multiply by the
Reciprocal.
reciprocal, which 3 times 3 would be 9. So could you get it to this point without a calculator? Yes. Now, 2 to the 7th you should be able to do, but 3 to the 7th gets a little scary once in a while. So we're going to put this in our calculator. So we have 9. Parenthesis 1 minus, put your 2/3 in parenthesis because you have to take both to what power? 7. And then end your parenthesis after that.
Why does yours only have those? Yours only have 2 decimal
Yours
places.
is 2.
Does yours have a bunch?
Uh-huh.
Yeah.
Oh, my mode probably says 2. See? Yours probably says float.
How did you do that?
Just hit mode. Do you have that?
Yep. Yeah.
Okay. Now, they gave us a fraction, so does anybody remember how to get this to a fraction? As I yawn. Does anybody remember how to make your calculator give them fractions? Math. See the fraction?
Math 1.
And then hit enter.
Dang.
So you get 2059 over 243.
Where'd you find that?
Math.
On your calculator?
And the first button, math, this is right here. And the first button is fraction. Okay, so it may ask you to write it in expanded form. Guess what this is? Expanded form. And it may say use the formula and verify by adding, only if it's not ridiculous, okay? But how far do you go?
26.
How much?
26.
26. Oh, then we weren't even supposed to do this today. Well, that's silly.
Well, then just listen to us on Monday.
I'm gonna have to redo them all anyway.